Hello hams and radio experimenters, Tinker Ham here. Today I'd like to teach you a useful trick with a generic scanning radio. You can use it to generate low-level yet frequency accurate and stable radio signals. Say for example you want to do some testing on a 2-meter radio, or do some antenna experimenting, or even test a repeater for descents. You can use this trick to generate the RF using your scanner with no modifications to the scanner. You've probably used one of these old RF generators. You probably also remember wanting to throw it across the room as it kept drifting off frequency. Trying to find 146.000 megahertz was nearly impossible. What you really wanted was this, but also didn't have the money to cough up to pay for it. It's also rather large, heavy, and far from being portable. So how about a trick for that old scanner you bought at a Hamfest? Or how about a desktop scanner that you've had laying around since the sale at Radio Shack? Most scanners would work for this. Most low-cost scanners are not really well shielded. You've got a plastic case on them, so the internal local oscillator tends to leak through the case and wiring and such. Well, here's the trick. If your scanner uses a 10.7 megahertz IF frequency, which many do, set the scanner to receive a frequency 10.7 megahertz above your frequency of interest. For example, I want to generate a signal on 145 megahertz, so I set the scanner to receive 155.700. When I do that, the scanner generates a dead air carrier on this frequency. An FM, that would just be full quieting. Most scanners that use a 10.7 megahertz IF, or intermediate frequency, to amplify the radio signals what they're normally receiving. It uses a local oscillator and a mixer circuit to get the desired signal to the IF frequency for amplification and then FM detection. This in turn has the scanner's internal PLL oscillator crystal referenced to 145.000 megahertz when you're trying to receive 155.700 on the scanner. We're really not using the scanner to receive a signal at this time, we're actually using it to generate one. If your scanner uses a different IF frequency, I have a second one here that it's on 10.8 megahertz. So I set the scanner to 155.800, 155.8, to generate a 145.000 megahertz signal. Experiment for yourself, see which ones work for you. Try tuning your scanner above or below the frequency of interest. See if you can find where your IF's at. Well, if you're able to do that, that's all well and good. You've made a dead air carrier. Yippee! But you've got no modulation. Well, here's a second trick you can use to generate some CW modulation. I'll program a couple of channels into the scanner and then let it scan in a loop. The first one I'll put in will be 155.700. Then I'll key in on the next channel 150.0. The channel after that, 155.700 again. The channel beyond that one, 150.0, and I'll just lock out the rest. Now I put the scanner on, turn the squelch up enough, and then hit the scan button and let it scan those 4 frequencies over and over. In doing that, the local oscillator will generate a CW pulsed signal, which when received on an FM receiver, you will detect a signal as quieting, then hear noise from the lack of signal, and then a squelch burst. And if this happens fast enough, you'll hear a rapidly pulsing ch-ch-ch type noise as the scanner's hearing the quieting and then hearing noise, then hearing quieting again. You can also generate FM using a stepped square wave method of plus or minus 5 kilohertz deviation. If the scanner scans quickly enough, switches across the channels, you can actually generate an audio tone. For this application, I'll program 155.695, 155.705, then 155.695 again, and then 155.705. That gives me 5 kilohertz above and 5 kilohertz below 155.700. And I will lock out the rest of the channels. If you also listen to it with a SSB sideband or CW receiver and get the BFO going on that, you'll notice the scanner oscillator, when it is locking in, can have quite a chirp to it. That might be useful, it might be annoying, but you can use this method to generate a signal in the 6 meter band also. For the scanners I'm using, I key in a frequency 10.7 megahertz below the frequency of interest because it's using a different injection into the local oscillator, into the mixer. 152.0 is my target frequency. Subtract 10.7, that leaves me with 41.3. So I key into the scanner 41.3 and bingo, there I've got a signal on 52.0. 440 works also. I just tuned 10.7 megahertz above that also. So in the next video, I'll show you how to do a couple of internal mods to the scanner. 73s, this is Tinkerham, signing off.